the scope of that function. The same thing is true for LUA. So for example, in LUA, if I want to write a function, I'm going to use the word function. We'll call this bar, like so. In Lua, the scope modifiers are not curly braces. So like in C and Java and C++ and Objective-C and all those other languages, we have the curly braces that denote the scope. In Lua, we have actual words. So these actual words denote the scope. So for example, the word end is the end of the scope. The word function is the beginning of that scope. If, for example, I say something like this, x equals 3 outside of the function, and then inside of it I say x equals 7, Lua has a special way to handle scope. If we did this in C for some reason, if I had an int x equals 3 somewhere else, and then inside of here I say int x equals 7, like that. Are those the same x in C? No? And those are not the same x because they're in different scopes, right? In Lua, are those the same x's? They are. So Lua has what we call is global by default. That means the scope is global by default. So the x that's defined inside of this scope is global. So this x and that x are the same x. So we have to be very careful about this. If you want to use local scoped variables, you have to explicitly declare them as local. And it doesn't matter. Lua can also use semicolons or not. Both of those are valid, semicolon versus no semicolon. In this case here, those two x's are different x's because this is a local x to this scope, whereas that's a global x to the entire scope. If I then use x afterwards, for example, x equals 10, because I declared, I'll do no semicolon on this line, because I declared inside of this scope the local x, that x refers to this x here, not the global x. Yes?
Any way to return it to the global?
So if I want to return it, I could say return x, but that does not return the value of x into the x here unless I call x equals bar. So I can return to the whatever calls bar, but I cannot make x go to that global x anymore.
Was that semicolon for this one?
Yes. So it doesn't matter. You can either use no semicolon or you can use a semicolon. Either one is valid. That's the reason why I did it. Well, Lua doesn't care about those two things. I mean, it does, but it doesn't.
How could you set like the global x to the local x?
So the only way to do that is then to call outside of the bar scope is to say the global x equals bar of some value, like so, and that would then the return value of bar comes out the same way that we would do inside of C or something.
So if you declare a local variable in the function with the same name as the global variable, you can't touch the global variable.
Correct. It makes it so you can't get access to that global variable. Technically, there is a way to do it, but we don't want to do that yet. We don't want to talk about that. Yeah.
Double minus sign is the sign for comments.
Correct. So in Lua, comments are denoted by a dash comment. If you want to have multi-line comments, you can do dash hard bracket comment hard bracket, and that would be the multi-line comment. Hard brackets are also the way we denote strings inside of Lua, or one of the ways we denote strings inside of Lua. So for example, I could say x equals hello world, x equals single quote hello world, and then I could also say x equals hard hello world. Like so. Yes, those are all string x equals hello world. Oh,
That's a way to do it multi-line, right? To just print out.
sorry, say that again.
Also a way to do it multi-line, right?
When you say, what do you mean by multi-line?
Something you can have something that you print.
You want to print multiple lines when you're saying, like print
that's
x?
like one sentence, like say like one single quote, different lines.
I still don't quite understand what you're saying. Okay, try it a couple times and maybe it'll answer your question. Other questions? So then why do we do this? Why do we have 3 different ways to define strings? Let's talk about it later. Why do we use the 3 different ways to define strings? What if you want a string with a double quote inside of it? Right? So in Java, for example, if I wanted to define a string in Java, string str equals double quote Sally said hi. How do I get those double quotes in there? You can use a single quote, but that's not how we do it in English. We want to use a double quote there. How do we use it? Someone else said it. We can use a backslash before. What is that called? To escape that character. Now, LUA is defined, is made for who? Who is LUA's target audience? Non-programmers. Do you want non-programmers to have to think about escape characters? No. So if I wanted the string, Sally said hi, I could say str equals single quote, Sally said hi. Oops, double quotes in the wrong place. Sally said hi with the single quotes. Those double quotes are now part of that string.
They all interchangeable.
So they're not interchangeable. So they're all the same, but they're not interchangeable in the sense like if I use the single quote to start the string, the double quote does not end it.
No, well, if I want the brackets to be inside, I can use the
Correct.
double quote side, and then
Absolutely.
if I want the single quote, I use the double quote.
Yep. Yeah. So if I wanted to have a single, like Sally said, don't, or something like that, I could say str equals hard bracket, Sally said don't. Like so. And so what this allows us to do with the hard brackets, we can actually make triple hard brackets and quadruple hard brackets. Those will actually define strings as well. Like if I did 3 here, I could actually do 3 instead of 2, and that would also define a string if I wanted to put 2 hard brackets inside of it. What it means is essentially you get a WYSIWYG. What you see is what you get, right? That string is what you see. That is also what you get in that value. You don't have to worry about having a special escape characters. You don't have to worry about how the new lines work. You can put new lines inside of it, and then when you print the new line, it'll actually print to multiple lines as well. What you see is what you get. WYSIWYG. What you see is what you get. And so that's very popular with non-programmers because non-programmers don't want to have to think about what you saw. What you see is not what you get. Okay. Does LUA have data types? Like for example, that's a string here, right? So does LUA have a data type? Yeah. Does X have a type? No. What has the type? The value does. The data does. So for example, the hello world here has the type of string. X does not have the type of string. str down here in Java, or in C or in C++, for example, str has the data type. The value also has a data type, but it's not as particularly important. Why in Java and C and C++ do we put data types on arguments, or on variables? We use the variables as containers, but X is also a container. So why do we do it in those languages? Why do we have a data type on the variable, not just on the value? Like in Lua, we can have the variable that has, I could just as easily then immediately say X equals 3, and now the variable X has an integer instead of or a number instead of a string. The variable doesn't have the type, the value has the type. Why in Java, C, C++ do we make the variable have the type, not the value? Sorry?
That allows for casting.
That does allow for casting, but it allows for something more powerful than casting.
You have like specific sizes for the data types?
That's absolutely true. That's true as well, but that's not the answer that really solves this problem. What you're saying assists in this compiling step, but it doesn't actually give us anything.
Sort of to allow
To some extent, the answer is correct. However, we're going to see why that's not true in general.
Wait, someone decided to?
Someone did decide to. Why did they decide to?
You can get members of that object.
We're going to find that that's not the answer. It starts off as that's the reason why you want to do it, but we're going to find with LUA that that's not true. So for example, if I said int x equals 3, and then I say float y equals x, and I did this in Java, would the Java compiler let me do that? What would the Java compiler do? It would either give me an error or a warning. The C compiler would do the same thing, and the same thing is true with the C++ compiler. It would either error or give me a warning. It would say, hey, whoa, wait a second here. This is a float, and you just gave it an integer value. This is particularly true for things like this. String z equals x. Well, I don't know how to do that. I can't do that. That's what C++ and C and Java would be able to tell you. No. You can't take that x value and put it into a string. Now, is this correct? Syntactically, it might be correct, but is it correct conceptually? No. Particularly, if I want to do something like this, I want to say int q equals z plus x. Do I know that z is an integer value? I have no guarantees that z is an integer value. Do I know that I can add the two of them together? I have no idea if I can do that. So this here is a protection mechanism. This allows the compiler to find concept errors or potential concept errors that you're unaware of. LUA will just as happily try to run this as not. What do you think would happen if we tried to run something like that in LUA? Like, for example, if I said in LUA, as an example, I say x equals 3, y equals hello, z equals x plus y. What happens? We're going to get some sort of error, right? Some sort of crash is going to occur. Z is going to break in some way. Because I don't know how to add the word hello, h or hello to 3. In C, I might be able to say y of 0, because y of 0 is an ASCII character, and add the two things together, and I can break that abstraction of that a string is actually numbers and all that crap. But in LUA, I'm not allowed to do that. LUA says, no, I don't know how to add a number in a string. In Java, Java would not add. What would Java try to do here? Concatenation. LUA does have a concatenate, which is the dot operator in LUA. That means concatenate. But in this case here, we want to try to add, and LUA will try to do this and then break, and then fail. When is LUA failing here versus when is C or Java failing before?
Would Java be at compile time and then LUA at runtime?
Correct. So why does that matter?
You catch our errors early.
Correct. So with Java, or some other strictly typed compiled language, the compiler catches our errors before we ship to the customer. Or before it's running, before it's live in some potentially production environment. Whereas in Lua, there is no compiler to catch this error. All that's going to happen is be like, no, I can't do that. Z fails. Now, did the line on Z actually fail, or did the fact that we assigned a value of a string to a Y fail? Because what if we had another function? What if this is what we wrote? Y equals 7, foo, Z equals X plus Y, and foo did something like that. If I didn't show you foo, would you say that this works? Right? That looks like it should work. But now we take a look at foo, and what happened to Y? We changed it to a string. That y is global. So then guess what? That y is no longer 7 over there. Can you know that without the foo function? No. And so this becomes much more difficult. Debugging this section of code here becomes much more difficult. And you're going to run into these problems, and you're going to be like, why the fuck? LUA is going to sound really cool in the beginning, and then you're going to get to certain parts where you're like, what the fuck is going on, and why are we doing it this way? And the reason why you get to that point is because LUA can't offer you the guarantees that the compiler does. And it doesn't try to. At the same time, when it doesn't offer you those guarantees, it offers you a different kind of power. And that's the kind of power that we're going to start to exploit. There's a data structure in Lua that doesn't exist in other languages, or well, it does, but it's the only data structure that exists in Lua, where there's many of them in, say, Java or C or C++. What's the data structure in Lua? Anyone remember? Does anyone know? Tables. The data structure in Lua is a table. So for example, if I say A equals curly braces in Lua, that's an X, I'm sorry. If X equals curly braces, that means that the variable X has a value that is a table. I can also say X is a table, but the variable X doesn't have the type of it. Tables are like arrays. So I can say, for example, X of 1 equals 3, X of 2 equals 4, X of 3 equals 7, and so on and so forth. What do you know? What number did I start with here? 1. Why did I start with 1? It's not designed for programmers. When before in Java, when we first said, hey, arrays start at 0, you were like, fuck, why do arrays start at 0? 1 is the first element, right? That's what we told you. And you were like, bullshit. Now I'm going to tell you, well, here's a whole bunch of languages that do it the other way, where the arrays start at 1. So our tables start at 1, not at 0 in Lua. And the reason why is because we have a non-programmer. Yeah, you have a structural engineer implementing some code that runs a turbine in your dam. You want to be able to start at 1 and not 0 and not have that off by 1 error that causes all those problems for them. This table allows us to do this array. What do you notice that I didn't do with my array or my table? Because it's not really an array, it's a table. That is neat, that I have to do in Java or C or C++. So yes, but what was the other thing? What did you say? The size. Do I have to say how big this is? No. I can make it as big as I want, or as small as I want. Lua doesn't have this concept for tables of finite size. This table is effectively infinite in size. As far as you can literally put any number inside of there and be like, all right, cool, I'll assign that value there. The other part of this is because it doesn't have a finite number of sizes, you can never go off the end of the array.
How does it manage its data structure?
Magic. We'll talk about that later. So, for example, if I have the table X, and I want to, if I say print X of 1, what is going to be printed there? The value of 3. Everybody's okay with that, right? But I also said that there is no limit to the size. And I can never go off the end of an array or a table in Lua. So I can also say print X of 10. What is the value of X of 10? So not garbage. It's an excellent answer. Garbage is absolutely true for any other language. Well, almost any other language. But in Lua, we don't have the concept of garbage. We have the concept of nothingness, right? Does X of 10 exist?
Yes.
The value of X of 10 is nothing, or nothingness. So you can also say that it doesn't exist. You can define it either way. And so if you want to say, yes, it exists, like all values already exist, just some of them are nothing, or some values, like X of 10, doesn't exist, so we return the value of nothing. Both of those things are correct. The value of nothing in Lua is nil, N-I-L, not null, N-U-L-L. Two different concepts. It's the value of nil. It means the value of nothingness. So in this case here, this will print, I'll do like a comment, this would print 3, and this would print nil. because the value of x of 10 is nothing, or nil, in this case here. The other cool thing about tables is that they don't care what you key them with. When I say key them with, what does that mean? So the index is here. So for example, that's a number, right? And we are used to indexing arrays with numbers, like x of 1, x of 2, x of 3. This 1, 2, 3, technically, the generic term is not index. The generic term is key. So for example, the key for the table of x with 1 is 3. LUA doesn't care what you key the table with. You can literally key the table with anything. Right? So, let's make a strange one. X of x equals x. Yes.
Does that mean some people start at 0 anyway?
Yes. The answer to that question is yes, because there's no reason why you can't start at 0. If I wanted to start at 0, I would just say x of 0 equals some value. But the built-ins, when you define an array, so like for example, I could define this table by saying y equals 7, 8, and 9. The index of that 7 is 1. The built-ins start at 1.
Do you mean everything though? Or like,
Literally anything.
like a question mark?
So when you say question mark, what do you mean by question mark? Do you mean the character question mark?
Yes.
Yes. So if I wanted to say the character question mark, I could say x of this. Well, let's make it a string because there are no characters in the string question mark equals let's say foo. We have the foo function somewhere, right? Equals foo. Literally anything.
So the x that you're assigning, is that the variable? Is it taking a reference?
So let's start on the very left-hand side. What is that thing on the left-hand side for you guys? That first part there is an x, right? What is the value of x? It's a table, right? Now this table internally has a memory address. And so like for example, if I said print x, just print x, that it's not going to print the table. It's not going to print all the values and variables. What it's going to do is it's going to print the address in memory of that table. So for example, it might print 74329 as an example. Let's say that's the address. I don't know. Probably has a bunch of x characters. That's what x would be. So when I say x, we actually get the table itself. When I index it, when I key it, the key is going to be the value at x. What is the value at x? That memory address for that table. And that becomes the key. Not the number, but the actual table itself. And then the result is x. Or the value of printing inside. So I know this is strange, and it's intentionally strange. So and we'll talk about how to use these guys here in a second, so I'm going to get rid of that for now. Let's suppose we've done this line. If I print x of 1, everybody's happy. Correct? If I print x, everybody's okay. We get this table, correct? If I say print x of x, what does that do? It prints the table, right? Because the value at x of x is the table x. The value at x of x is x. So x of x is x. If I say print x of x, that returns what? The table of 1 prints 3. Is that recursive? Absolutely. It's weird. We'll do it again.
So you just made it a member of itself keyed to its memory address?
Yeah. To itself. You don't want to think memory address, because LUA doesn't really think memory addresses. It does print them out, but it doesn't really think that way. It is actually the table as the key.
So could you like have x
X of X.
Absolutely, it's a loop. It's an infinite loop. Yeah.
That's stupid.
So I didn't say this was smart. All I'm doing here is demonstrating the point that we can literally key anything with anything to get any value, even itself unto infinity. So for example, I can say, actually the only thing we can't key on is nil because that's not, but I'll take that back. So to do what you just said would be x of x. The result of x is x, right? So I can take that of x again, right? Of 2, which would be that 4. Because this x of x, what's the value of x of x? X. What's the value of x of x? X. What's the value of x of x? X. X of 2 is 4. Your face says it all. What was the comment over here? What was your comment? So x plus 1, like if I said print x plus 1, like this, x of x plus 1, so that's the same thing as saying x of plus 1. So if you did, for example, oh, you mean like this? Like that one? Oh, that's a really good question. I have no idea. I would imagine, actually, my guess is that this x plus 1 will fail because it doesn't know how to add a table and a number. I'm pretty sure that's what will happen, now that I think about it. That will fail, and so this will fail, which will cause that entire line to not execute. Does that help? Good question, though, about x plus 1. Because in C and C++, we can actually absolutely take pointer plus some value. We can't do that in Lua. Pointers in Lua don't allow you to add them to, because they're not really pointers. They're not really memory addresses, even though we print them. Excellent question, though, by the way. Other questions? Okay, so we can key on anything, correct? Which is kind of a neat concept. If I can key on anything, what's the first thing, or what's the first kind of thing we need in object-oriented programming? A name for an object, right? X. That is now the name of the object. What else do I need about object-oriented programming, or about objects? Say that again?
The superclass?
The class implementation?
The superclass, like the
hierarchy?
class that it inherits from?
So you don't need that yet. That's actually might be significantly later. We're going to get there now. Some function that sets it up. But before we even get to a function that sets it up, well, and you're right about that. We're going to get to that. We're going to get a little bit farther. There's even something more fundamental than that. Member variables, or member things, right? So for example, if I said in Java, I could say class X, curly braces, and then inside of here I'd use things like int X, int Y, so on and so forth, correct? And what that does is that defines a class, let's call this not X, let's call this N. Let's call this This defines this class foo, so I can make objects of type foo, and those objects have inside of them an X and a Y, right? Object-oriented programming requires that we have things that have stuff inside of them by name. So for example, by X and by Y. That's the first step. This is the reason why when we talked about structs in C, we can make a struct in C, and that kind of started to be object-oriented programming-esque. Not completely object-oriented programming, but programming-esque. Well, if I can define a member inside of Java language like this, where I have the variable, like variable name X here, I can do the same thing here by saying X of, somebody give me a variable member. What kind of object do you want to make?
Monkey.
Monkeys? All right, so let's call this monkey then instead. What kind of things can monkeys have? monkey of bananas, right? Let's say that bananas is going to be the quantity of bananas that it has, and so we can say, for example, 3. Like, this monkey has 3 bananas, in this case. And so if I said print monkey of bananas, I would get 3, correct? What we've done is we've kind of said that bananas, the string bananas, is a member of monkey. This is the way we talk about this data structure with tables and things like that. Now, LUA knows that we want to be able to do this. So LUA has implemented a piece of syntactic sugar that allows us to access bananas without the array notation. The same array notation, they do the same set or the same get. I can also say print of monkey dot bananas. Oh. Right? So this is syntactic sugar. Do we need the ability to use the dot operator to get to bananas? No. But it makes it easier to use. So for example, if I say monkey dot bananas, I'm really saying, hey, I want to get the bananas member out of the monkey table. So monkey dot bananas is equivalent to 3. So that's going to print out 3. Does this look somewhat familiar? Right? And so if you're looking at an object-oriented programming language, you often see object.member to get access to it. That's what object-oriented programming is. Well, what is an object?
Yeah.
When we talk about an object, usually what is it?
It's a new data type that the compiler can use.
That's true. So when we instantiate it, when we actually get an object, what does it look like?
Set of individual variables and their values.
We can draw it like a box, like we've done before, and I can say, hey, this is a monkey. Monkeys have bananas. Right? Have I drawn a box like that before? Have you seen something like that? If I want to get the bananas part of it, well, what if I just said, hey, this is now an array, where the thing on the left is the key and the thing on the right is the value. It's the same concept of doing this over here. All object-oriented programming languages do this.
So can you index something at position 1 with monkeys.1?
No, so it has to be a string.
So numbers and strings are hashed differently.
Correct. If you do the monkey.1 with the number 1, I think it depends on the version of Lua that you're using, whether or not it'll accept that. I think the one we use does not. I think the previous versions used to, and then they took that out because it is not intuitive which one that is. Because in Lua, monkey of 1 and monkey of 1, those are 2 different things. That's a string and that's an integer or a number. Those are 2 different types. And that's the point that you're making. In this case here, if you use the dot, it's referring to the string, not the integer. And I don't know if which way they made it work. So this allows us to get to this object-oriented structure concept. So now we have this idea of objects, essentially. We have this idea of stuffness. I can put a banana, valley inside. Well, what else do objects need from object-oriented programming language besides things, besides stuff to put inside of it? Functions. We need to be able to put a function inside of it. Well, since I can key on anything, what can I put as the value here? I can put a method there. I can absolutely put a function. And it's not just a function. I can put anything over here as well. I can take the table indexed on anything, keyed on anything with any value. So I can absolutely put a function on this side over here. Let's define a function for monkey. Monkey. What function are we going to define for monkeys? Okay, let's call it throw. Monkeys can throw, right? So I'm defining it this way. I don't have to define it this way. We're going to define it 2 different ways here. But monkeys can throw. Now when I say monkey throw, I'm assigning that to the value of monkey throw is going to, what do I want it to be? A function. So I'm going to make it a function that takes, let's make it take an argument str. So that parameter, str is now going to be passed to it, and we're going to say print the monkey through, how do I concatenate this string with that string there? The dot str, like so, and then I'll say n. Monkey of throw equals that function string, str. What's weird or strange about this definition or declaration?
Everything.
Everything. Huh?
It doesn't have a name.
It does have a name.
Oh.
Monkey of throw is its name, right? So, but you're right about this. It doesn't have an identifier. Okay. So when we're drawing our picture, we have this thing, which is a function, which does some stuff. This is a func. That's our function. It does some stuff. Does it have an identifier? Do functions need identifiers? And this is a weird question. Now, do values need identifiers? So for example, if I wanted to have the value of 3, so I have this box and I put the value of 3 in it. Do I need to give that value a name? So I don't need to. But what if I don't want this to go to waste, I do have to be able to give it what? So we know that it has an address because it exists. By when it exists, it has an address, because when it exists, it'll be in memory, and that means it will have an address. The fact that it exists gives it an address.
We need some way to access it.
We need some way to access it. And there are multiple ways that we can access it. We can either give it a name, like foo, for example. We can either say food, it has a name, and then we can say, let's use foo. Or we use a pointer. Maybe the person who said address meant to say pointer. You put a pointer to it from somewhere. Wherever that pointer comes from can access that value there. Does that make sense? The same thing is true for functions. When we define functions in C, and we define functions in C++, and we define functions in Java, we typically define functions that have names. And this is one of the biggest limitations that Java had until Java 8. And Java 8 just implemented this, like 6 months ago, something like that, December. Java did not allow you to have functions without a name, without an identifier. And this was the biggest limitation that Java had. If you can't have functions without names, we call these lambda functions, it means that you can't point new things at them. The other name that we give these kind of functions is delegates or lambdas. Those kind of things. Those are the way we talk about those. Without delegates and lambdas and functions without names, user interfaces are exceptionally difficult to do. And hopefully you'll discover that over time, but for now we're going to take it at that. If we don't have a name here for this function, I still have to have some way to access it. So what I'm going to do here is I have throw, which points at that function. Like so. Yes?
Is this the reason that Java's swing is so terrible?
Yes. This is the reason why Android is stupid hard to program. It's also the reason why Java 8 has delegates and unnamed functions, is specifically because Android needed them. If you've ever done Android programming and you've tried to figure out how to make a UI function work and you're like, why the fuck does this require so much syntax? It's because they don't have the ability to do this in Java. This is the reason why.
It doesn't have a name throw.
So this is the name. So you're right. But does it have to be the name throw?
No.
No, I can absolutely later say monkey of throw equals the value. Let's say this is throw equals 3, right? That would make this value go from that pointer to that function to the value of 3. Now does anything point at that? No. Can I use that function anymore? No, it's gone. You're absolutely right, though. It does have the name throw until we get rid of it.
Why is that useful? I don't really get it.
So, okay, good question. The reason why it's useful is that we can rename things dynamically. So currently, what is throw?
The function.
That function over there. What if, as the program is running, I want throw to be a different function?
Okay, why would you do that?
So let's consider you have a user interface, right? And when you click on a button, you want something to happen the first time they click on it. The second time they click on it, you want something else to occur. Right?
Yeah.
And you can and so in Java, you couldn't have, it was very, very difficult to have a button that did different things based upon the number of times you clicked on it. Right? And this functionality, this method here allows us to do that. And you can see, I can redefine throw to be anything. I can redefine it to be another function that would be over here if I wanted to. Right? At any point in time. That's the power behind it. Yes?
Is it extremely valuable for machine learning?
It can be. It's part of the reason why we use Python a lot. For machine learning, Python has the same functionality. You can do the same thing in Python. Sorry?
Because it can change with different inputs.
Mm-hmm. Yeah.
Functions.
So the other thing with this kind of method, this kind of processing is, not only can we reassign it to a new function, we can write functions that produce new functions. Right? This is a weird concept. So this is what we're going to do. We're going to write a function that reproduces a new function. We're going to come back and see how we can do this. We're going to call this function produce adder. Add value. So the function that we're going to be writing here is going to create and then return a function that add value to whatever it takes. This is going to be a little weird. So what this is going to do, we're going to use it the following way. We're going to be able to say, for example, add1 equals produce adder 1. Then I can say print add1 to 2. What do you think this would print? Just as a guess, based on the names. 3, right? So add1 is a function that adds 1 to that value there, which would result in 3. Add1, the function comes from this concept of producing, of this function over here. We can also make an add2 function. What do you think that one would print? 5, because it takes 3, it adds 2, which is 5, and it prints out 5. Now we're going to have to figure out how to write that function, but does everyone have the concept of what we're going to be doing? So this function, produce adder, will make functions that add things to them, based upon the argument 2 here and 1 there. That's what we're going to be doing. Does anyone have an idea on how to do this? So, do you have an idea? Do you have an answer? Or do you have an idea? Okay, let's hear your idea.
Probably going to start by returning a function.
So that's what we have to do. Since produce adder is going to be returning a what? A function. Let's return a function. Return a function. Is this function going to have a name? This function does not have a name. It will get a name. For example, it will get the name add1 and it will get the name add2, but that will happen later. The function inside of here does not have a name. Does it have an argument? Right? That 2, so in here we have the 2 here is an argument to the function that we were returning, not the function to produce adder. That 2 is the function, and that 3 is that value that we're going to be doing. So we're going to take a single argument. So we'll call this val here. Like so. I'm going to go in and end this function here. So this end ends which function? That one, right? This end down here returns or ends which function? This one up here. The same thing as with the curly braces. What is this function going to do? It's going to add val and add val. Right? We're going to return that. Return val plus add val. Questions about this function here? Yes.
Just to clarify, the semicolon's completely optional, right?
Yes.
So if you were to take the monkey throw and put the function on a new line, just for readability, it would still be able to recognize that, or because there's no...
When you're like if you have like an equal sign with nothing on it, and you have it on the next line down.
Yeah.
We're going to learn how to fix that in just a second. We're going to fix that problem.
Say if like when you're defining it over there on the left, if you had one, if you had one as like an integer, and then in your print you had a float, would LUA take care of that, or would that be?
So Lua doesn't have a difference between integers and doubles. It only has one data type for numbers, which is number. So all numbers are numbers. Good question, though.
So in the inner function, add value is not a reference to add value, but it's actually the value of add value.
So no, it is a reference.
So when the function's returned, it becomes that value.
It is part of the reference.
So after this, the scope is after it's out of the scope of the outer function, that reference to add value is kept. So add value that you passed in is still in memory.
Correct.
And just because it's not garbage collected because it's a part of the inner function.
Correct. Did anybody else understand the question just asked? Okay. What I'm going to do is I'm going to draw a little picture over here. I'm going to erase this and we'll write this back. So when we say add 1 becomes produce adder, what we have is we have the variable add 1. It becomes a reference to this function. That function has some code inside of it. This function that has code inside of it, how many arguments does this function take? Takes this one argument over here, which is val. It also has a reference to this thing called add value. There. Because the add value, when we say add 1, what's the value of add value? What's inside this box right here? That 1 right there. When we say add 2, we have the same thing. We have a function. Function has a reference to what? Add value. Now, is it this add value up here? Is it the same one? Or is it a different one? The answer to that question is that the parameters here are local. Parameters are local to a function. This is what the difference between global and local means. So when it means parameters are local, that means that it gets its own copy of this thing called add value. Add value, which would be 2. So this is what it would kind of look like here in generating those guys. Questions about that? I don't have quite enough time to demonstrate it, but we'll do a demonstration next time we have a lecture of something like this.
The demo we had earlier with x equals 3 and then function bar, and then you had to create local x equals 7. If you, instead of add value x, would it automatically do local x as well? So all your
So if, for example, I declared inside of here x equals 1, as an example of what you're saying, and I use an x inside of here, this would be the global x, not a local x, because this x is globally defined.
No, I mean if you had a globally defined x equals 1, and then in your function code, instead of the name add value, you add the name x,
Yes,
it would
be the global x.
Oh, it would
Be
be
the global x.
oh, it's still-
Unless this was the parameter was the x.
that's what I'm saying.
Oh, if the parameter is the x, it would be the local x.
So to create a local x with the values submitted.
Whatever this guy has.
So you
Okay, so this is the concept of having functions without names. This is the concept of functions returning functions. This is the concept of functions with pointers, like so. And all of this gives us the ability to have objects with both values, like the value 3, and functions, like so. Any questions about this so far? Yes?
Is there a way to achieve protected variables?
There is, but it is much more complicated. We're not going to cover it in this class. Other questions? Yes?
So polymorphism is just a part of LUA?
Polymorphism is not a part of LUA, but we do get polymorphism for free with LUA. And it's not that so when you say that polymorphism is a part of LUA, that's not true. LUA does not concern itself with polymorphism. It doesn't care. But the concept of polymorphism is gained for free with LUA. And we'll show, and this is part of the concept of polymorphism here, but we're not quite there yet. We're going to see how polymorphism works in other languages, probably next time, because we don't have enough time to cover it for the next step. Other questions? All right. So this notation here, monkey of throw equals function, is difficult to read. It's also somewhat difficult to write. What an easier way to do this is to do the following. Suppose that I have monkey defined, like I defined before with monkey equals bananas. So let's actually do it again over here. Monkey equals this table. Monkey dot, that's a y, dot bananas equals 3, like so, right? I want to also be able to define the function throw easily inside of monkey. Lua also has the syntactic sugar to allow us to do that. We can do the following. We say function monkey.bananas. No, that's the wrong thing. Monkey.throw, sorry. Monkey.throw. And this solves that problem of it being difficult to read that monkey of throw is that function without a name. In this case here, we define the function with the name monkey.throw, which is the reason why earlier you said it has the name monkey.throw. You're right about that. It does have the name monkey.throw. But the fact that it is named that is irrelevant. And that all the names are fluid, and we can rename them at will. And it's the same, but this is the syntax that makes it easier to write. This is the syntax that is somewhat similar to C++, and then we didn't do the C++ object-oriented programming syntax, but this is the one that's similar to C++ object-oriented programming syntax. Java is also similar in the sense the only difference is that we don't have monkey inside of the class, we just put the function throw inside of the class, but this is the way that we do it here in Lua.
So if we created a throw variable and then we just said equals monkey.throw, would you be able to then submit a variable to that?
Yep. Yep, it'd be the same thing. So in this case here, we have the same structure we built over there, and what he was just asking was if later if we said something like, let's call this foobar, to give it a funny name, foobar equals monkey dot throw. Well, monkey.throw is this function over here, so I can also have this variable foobar, which points at that function over there. So I point at the same function. Yes?
You didn't want to use monkey.throw anymore and you wanted to use just foobar.
Mhm.
How would you just like throw away monkey.throw?
Monkey.throw equals nil.
And foobar would be fine.
And foobar, so this is what exists. Foobar and monkey.throw point at the same thing. Monkey.throw equals nil, so throw goes away. And foobar would still point at function.
Can you initialize the members of monkey inside of the list initializer?
Yes. So that's the next step. This here is a little bit difficult to keep track of, and so we go, screw it, I don't want to do it that way. So if I want to be able to initialize them easily, the next step is to be able to define them as an array, like an array. So earlier, as an example, we had x equals 7, 8, 9. Like, I don't know what I'm doing with those guys, etc. Where 7 has the index of 1, 8 has the index of 2, and 9 has the index of 3. 1, 2, and 3. We looked at that in the very beginning of class. We can just as easily say monkey equals 3. And then write the function as well inside of your function. We wanted to write the function. What's the index of 3 right now? And the index of function? 2. But we don't want to index on 1 and 2. What we want to do is we want to index on bananas and throw. So we can do it like so. Bananas equals 3, comma, throw equals function, curly brace. I would actually put the curly brace like this. So the curly braces are wrapping that guy right there. Suddenly, if I took that equal sign out there, and I put the word class over here, it looks a lot like a Java class, with commas instead of semicolons.
Do you not need quotes around bananas and throw?
You do not need quotes around bananas and throw when you're doing it this way. Bananas is taken to be strings. Anything that you put on this side over here is taken to be a string, not an integer. Yes?
And then could we still do the function like that?
Yes. So if you don't like to do this function declaration where the function doesn't have a name over here with the throw equals function without a name, you can define it like this. Define that, and then you can say function monkey dot throw, that's a Y, dot throw as well. And that allows you, that almost looks exactly like the C++ object-oriented programming definition. The only thing it's missing is public-private practically. Monkey dot throw. I thought I put the dot there. Sorry. I did, but I overrode it. Monkey dot throw. Correct. Okay. Yes.
So if you were defining it in line with monkey, well not in line, but within the brackets, you put the comma after the end of the function?
Correct. So what we've done here is we've looked at LUA's kind of loose syntax. LUA has relatively loose syntax. You can do a lot of different declarations. And what the big part of it is, when we do this here, when we say monkey.throw with the function over there, that's a simplification of the earlier step where we say, wherever the hell it went, oh, maybe I erased it, where we had the monkey as the table, key throw equals that function. That's a simplification of this process. But this is a simplification of that process. The big concept, and this is true for all object-oriented programming languages, is you get, when you have an object, really what you have when you have an object is a set of memory. And a set of memory is really just an array of bytes. And you need to index into that array of bytes somehow. And when you're indexing into that array of bytes, you're going to index based on the keyword of the thing that you want to get out. And Lua just defines its language to be that way. Its object is a table with indexes that are strings of the things you want. And then it has a couple of simplifications, like monkey.throw allows you to get to the throw thing inside of monkey without having to do the erase syntax. Wherever it is. Otherwise, it's the same. Next time we'll talk about how to actually do inheritance and polymorphism. That's the next thing we'll cover.